I'm talking about validating big data and ML pipelines. I mostly work in Spark with a little bit of Beam, and so that's where the examples are from, but these techniques should apply regardless of the tools that you're using. And the full title is Avoiding Awkward Recommendations. And this comes from some times when I've made some awkward recommendations in my life, and I'm not talking about Bud Light Lime. So my name is Holden. My preferred pronouns are she or her. It's tattooed on my wrist, which is really convenient in the mornings when life is a little fuzzy. I'm a developer advocate at Google. This is nice. They pay me money, and I check my work email. I still work there. And I'm on the Spark PMC, which is like being a committer, but it is really hard to get rid of me now, so that's exciting. I like to think of it like tenure, but then my friends point out that I don't get paid for that, so it's not real tenure. And I also contribute to Beam and some other stuff. I've worked at a bunch of companies, and I'm a co-author of 2 books on Spark. The more recent one has a much better royalty deal, and so I strongly recommend that book. It's not a good intro book, but I'll make more money on it. And you can follow me on Twitter, Slides. If anyone's really curious about how large open source projects do code reviews, I started doing live streams of them when I was informed that I needed to make a bunch of video content. But also, I think they're fun, and hopefully I can trick some of you into helping me review more open source PRs, because we have 500 open pull requests, and I don't have that kind of time. And if you've got feedback on this talk, there's a link at the bottom. You can fill it out. If you have questions, there's a Slido thing. So far, none of the talks I've been in have actually had questions coming on it. Maybe you will today, maybe you won't. That's fine. Okay, in addition to who I am professionally, I am trans, queer, Canadian, in America on an H1B work visa. It's a really fun time to be here on an H1B work visa and part of the leather community. And this is perhaps not directly related to distributed systems. There is no secret Canadian garbage collector we've been hiding from you. If there was, I would try and sell it to you. But yeah, I think it's useful to remember that we come from different places and to talk about that. And if we realize that all of the people we have solving a problem do not come from different places, maybe that is time to see if we need a different team so that we don't just make yesterday's biases stronger with computers, because that would be really sad. And yeah, I don't want that. That's why you should, yeah, okay, anyways. So I'm gonna cover a few different things. We're gonna talk about property testing as a lead-in to validation. We'll talk about what validation is on these pipelines, why you should do it, simple rules for validation, some of the constraints that we live in these systems, and then I'll do some more talking about ML-specific things. Really curious, how many people here do machine learning-y stuff? Okay. How many people use Spark? Yay! How many people use Beam? Okay. Dask? Ooh. That's exciting. Does anyone, oh, okay, one person is very excited for Dask, yes. Does anyone use another data pipelining system that I didn't mention? That they, Flink, oh, I'm so sorry, yes, Flink. Most excellent. Anyone else? Okay, cool. Well, so the nice thing about all of those systems is we can apply the same techniques, and the only part that you have to do is change your code. That part just, that's easy, right? So that's great. So I'm hoping you're nice people. You laughed at my shitty intro jokes, so we're good. If you don't like pictures of cats, this is not the talk for you. There are many other talks happening. It is all right if you want to leave. No worries. I'm hoping you're familiar-ish with one of Scala, Java, or Python. And if you're not and something doesn't make sense, you don't have to wait until the end. You can stop me and we can explain the syntax. And I'm hoping you want to make better software. If you don't, then maybe your boss wants you to make better software. I don't know. Alternatively, you're just here because you're like me early in my career when I was like, oh, I need to test this stuff or I'm going to get fired. And then that's a pretty good thing too. I enjoy not having to try and transfer my work visa. So yeah, okay. Ooh, so why should we test? It makes us a better person, avoid making users angry, et cetera, et cetera. Since you're here, you probably already care about testing, but if there are other people in your organization who don't, you can remind them of the exciting fun of having your ML jobs fail on hour 26. Yay! And we don't have recoverable checkpoints. Yay! Okay, and so not only will it save you money, it'll save you time. Okay, why don't we validate? So I think there's a lot of good reasons. Why should we validate? The first one is your test coverage is probably not perfect. I am lazy, and tests are one of the things which may occasionally get left by the wayside. We can find ourselves in situations where there is a part of our code which is just really, really hard to test. Or even if we do manage to have good test coverage, we may not actually cover all of the wonderful kinds of data that the real world is going to come up for us with. And at some point, we are going to be aboard the failboat. That is just a fact of software engineering. Eventually, we all fail. Hopefully, we fail together with a team, so it's not a lonely experience. But it's better to know when you're failing. If you find out when your customers call you, that is anxiety-provoking. If, on the other hand, your internal tools can tell you that something has gone amiss before your customers find out about it, your life will be much better. And you have a lot less explaining to do, and you can pretend that your software works, which is really what we all want to do at the end of the day, is pretend that this stuff works. Okay, so the other reason is a lot of people deploy their stuff automatically into production. That's really great. I'm glad you deploy your models frequently into production, but I'm terrified because I've been there, and I'm terrified because of the next slide, where about 15% of people have had a serious production outage, and the remaining, let me read it here, 32% had an outage that they didn't consider serious per se, which I take to mean they didn't have to update their resume, but some customers were a little upset. And the remaining 52% are working on mnist.csv. There's nothing wrong with working on mnist.csv, but you're not super likely to get a production outage. So, okay, why don't we test? It's hard, our tests go slow, it can take a lot of time. Testing distributed systems is particularly annoying. I'm not gonna ask you to admit if you don't test your code. That would be unfair, but the other part is notebooks. How many people love notebooks? Yay! How many people love the testing experience with notebooks? Yeah. And so notebooks are amazing, and I think they've made data pipelines accessible to a lot more people, and that is really good because I am lazy. And other people doing this work is the key to me eventually retiring. But if they do it without tests, it's the key to me never retiring and being sad all the time. And I think notebooks are really good, but we maybe need better tools around testing them. I don't have an answer to that part. That's just, we're screwed, but that's fine. So we don't validate because we tell ourselves our tests are good. We think, what could go wrong in production? And then the other honest part of it, at least for me, is that making validation rules with distributed systems is a lot harder, right? Like, if I'm collecting metrics on one machine, it's a lot easier to write rules about like, hey, when you see your CPU go to like 95%, maybe we should like take a look at that. But when I've got like 200 machines doing a job together, it's like work. The other one is that they're not always deterministic, which is just great. Everyone loves the fact that we recover from failures. It's better than failing, but sometimes it's better than failing. Sometimes this quasi-non-determinism can make actually figuring out what's going on hard and creating correct alerting really difficult. So what happens when we don't? Now, there is a video camera, so these stories will not be mentioning any of the wonderful, I assure you, small independent vendors that I worked at when I was there. by name, but we can talk about some of the things in sort of the abstract. Some words have multiple meanings. Some of them are appropriate for minors, and some of them are not, but the word is spelt the same. And that's okay if you have a good system for flagging which products you probably don't want to show the small ones, yes? However, if someone changes the meaning of that field and you don't have any validation on your input data, and all of a sudden, all of the products are viable for everyone, you have a very exciting 15-minute SLA to respond to. Right, what was the other one? Oh, yeah, just straight up costing money. Personally, I would much rather lose my employer money than have to explain to people why we showed small children things. Almost recommending illegal content. This was like the low point of my career, and we only got lucky because we happened to spot check it that day. Yay. And that also came from a wonderful schema change. And there's people who have really great tools to prevent schema changes without, refactoring all of the downstream consumers of your data, and I think that's great, and we should all do it, but what I've noticed is when you do that, people just change the meaning of the field, because changing the schema is hard, but what about if I just stop populating it? I'll just not take it out of the schema, because then I have to refactor everything, but if everything just becomes null, that's really my downstream consumer's problem, right? The only problem is there's a good chance that you work at the same organization and they may be able to find your desk. Now, thankfully, I work for a megacorp, so finding my desk can take some time and I work from home. But this could matter to you. Oh, right, and there was another time, and this one was more funny, because all of my validation tests were written for coffee shops because I like coffee a lot, and then I ran them, and I was like, excellent, all of our search results are finding coffee shops just like they should, and I pushed it to production, and someone told me that Starbucks was not a steakhouse. I did debate that their new breakfast sandwich offerings were food of a sort, but it did not go well. Anyways, okay, so hopefully I've convinced you that this is important. If I haven't, it's fine. You can just fall asleep. There's also the internet here. It's very great for distracting you if you don't want to snore. So for tests, I think one of the things before we get too deep into validation we should talk about is what kind of data people test on. Because if we're testing on our whole production data, maybe our tests are going to be a good indicator of what production looks like. However, that is 15% of people. How many people here can run their tests on their full production data? Okay, we've got one. No, two? Okay. We have 4 people, one of whom is probably, how do I say, optimistic. In my experiences. I've certainly believed that I was testing on my full production data, only to discover later that there was extra bits in real production. Other people sample their production data. This is pretty good. However, that you might find that you have these really weird corner cases that can really screw up your recommendation systems. And yeah, cool. Okay. Right, property checks. How many people are familiar with property checking for testing? Yay! Property-based tests are amazing. I like them because I don't have to come up with examples. And if people ask, I'm not all that creative except when it comes to my wardrobe, which, purple dinosaur is a good sample test. But for actual data tests, I'm like, well, let's try null and the number 6. But it's big data, so we'll try the number 1, 2, 3, and 6. But it turns out that we need to use 1 million entries. I feel really old. Oh, okay. It's not that I'm old, it's just that people didn't find the joke funny. That's fine. So we can write property checks and we can ensure that our important business logic function does not drop any records, right? And we can write other things like this. And the nice thing about these property checks is we can actually start to flip them on their head and consider how we can use them as validation rules, right? Like, if we know we have a thing which should not lose any records, well, that's a good thing that we could be asserting at production. Or maybe not asserting, because assertions are scary, but at the very least, logging to a file for someone to ignore. Okay, cool. Oh yeah, and it turns out that if you actually want to do property checking with 1 million entries, it gets a little slow, and there's a bunch of things you can do to speed it up. I'll post the slides later if anyone's curious about that. So let's focus on the main point of the talk, which is validation and all kinds of fun. So how do we do this? The idea is, and I think to a degree, at one point your software worked, right? Validation is not gonna help us really in the case where our software has never worked, but if we're in the case where like it used to work and we want to make sure it keeps working for at least the tenure of our employment, validation is a great tool there. Maybe we manually tested it, maybe I tried searching for more than coffee shops. You know, I searched for coffee shops and steakhouses, and I got 2 results that were not Starbucks, so it was good to ship to production. But we can't do manual checking every time, in part because a lot of our companies fired all of their manual testers. Yay, quality. This is being recorded, so I'll shut up. But, you know, and the other part is that people expect faster turnarounds now, right? Like, in the days of, like, taking a week to train a model, adding an extra day to let it sit and have someone look at it and be like, I wonder what this says about Pikachu. Let's see. Was like an acceptable delay. But when we're updating our model daily, people don't like an extra day of delay for you to be like, I bet there's something silly about Pikachu in here. That's no longer an acceptable solution. Okay, so how many people have some code in their data pipeline that looks something like this? You take in a record, you try and parse it, and if you fail, well, let's just drop the record. It's JSON, so it was probably just malformed. Am I the only person who writes bad code here? No, okay. There's a lot of people and some laughter with a conspicuously not raised hands from large companies. And that's fine. That's fine. So I'm going to assume that maybe you don't have JSON data, maybe you have XML. It's fine. I worked at IBM too. No, and XML is lovely, but occasionally we might get parse errors, and that's okay, right? If we failed our data pipeline every time we encountered a problem with a single record, there is a good chance that we would not have a data pipeline. Or we would have a very nice decorative piece, but we would not have any production-ready models. And so we end up writing code like this, and that's okay some of the time. But unfortunately, if we don't produce any data, we will normally notice, and that's exciting, and if our model is empty, our cat will be very hungry, and this will be very sad. The empty cat food bowl is not a good ALS predictor. So we can validate, you know, we can filter, we can write some rules, then we can check the counts, and we can put some special business error handling logic there. Very special, very business. It's a Motorola pager. Or nowadays, it's probably PagerDuty, but the same psychological effects on your team. Okay, so the other part is, who wants to write their code to look like this every time they're doing something which might accept some of the records? I've got like one person who was like, yeah, I do this, but now they're shaking their head, so I don't know. Okay, so part of it is writing your code like that is less fun. The other part of it is, by doing this, we tend to break the optimizers in a lot of things. And the other part is doing this in a system like Beam is actually surprisingly complicated because it does whole program evaluation, and so getting intermediate counters out of it can be quite challenging. And so stopping in the middle of your pipeline is pretty much a no-go without an exception, and that's all kinds of sadness. And so generally, this will make our jobs slower and use more cloud computing resources. That being said, I work at a cloud provider, so this is not all bad. Like, I sell you CPUs by the hour, we're good. But we can use counters instead, to the rescue. And counters in Spark are like our friends, but the friends who kind of took our lunch money. Okay, Okay, you all had much more healthy sort of like early education experiences. But the nice thing is Beam and Spark have their own counters implementation. Lots of other things have their own counters as well. They track their own metrics, but we can add our own metrics on top of it, and we can pretend we're still writing functional code, because we won't put that if statement in the middle, we'll hide it. And that is like not having a side effect, right? We just put it in another file. So that's what we'll do. We'll take this and we'll make a happy counter and a sad counter. And we'll put our special business data logic processing down there. We'll do the processing, and then at the end of our job, after we've waited 12 hours, we'll check to see if our data was good. Who likes this approach? This is, damn, tough crowd. So the other one is, we could actually not save our validation necessarily to the end. Some other people do some nice things where what they do is they essentially write code like this, except instead of running as part of their main pipeline, they have a data quality checker that runs either alongside in a separate process or on the same cluster to validate that your inputs are actually reasonable. You don't block your main processing pipeline. You can have your ugly code in a separate file. It'll do its counts. But it's separate, and it can still stop your job if it realizes that 90% of your customer records have been replaced with the word cat, right? So that'll help too. Okay, so that being said, ooh, I meant to change this slide. We'll pretend that slide didn't exist. Okay. Okay, let's go back to, okay, so how many people have used counters in Spark or Beam or Flink? Okay, cool. Not a lot. So before you do, I want to be clear, the counters stealing our lunch money wasn't just a joke. They're also really unreliable. And so it's a really great thing to use to protect our data. Yeah. Wait. Okay. Oh yeah, okay. So you know the joke, I have 99 problems, but I have a regular expression, and now I have an uncountable number of problems. But that's okay, counters are similar, because what will happen is you can write your tests, you can use counters, and then when you run your code locally, it'll look like it's working. And that's the best code, is the code that will behave differently on your laptop and on the cluster. And counters are that code. Yay. That being said, I don't have anything better. This is sad. But essentially, there's a reason that we have to keep track of our successes and our failures. And that's because of how Spark handles recomputation, and because Beam has different engines which handle counters in different ways, and because I don't actually know how Flink implements their counters, we need to essentially accept that the same data may be processed multiple times, just for good measure, and then we'll just count it a few times. And so if we used absolute numbers, if we said like, reject more than 10,000 bad records, there's a chance that our 10,000 bad records could actually be one record that was parsed 10,000 times. Yay! But if we do it as a percentage, it'll hopefully work out, kinda. Yeah, cross your fingers and push to prod. Okay. So what do other people do besides adding counters to their data processing? According to a really depressing survey that I run, most people's only validation rule is checking how long their pipeline takes. And the idea is, if it takes a really long time, something has gone bad. And if it finishes really, really quickly, you're either a genius programmer or something has gone bad. And in my experience, normally something has gone bad. And checking execution time is good. The other one is we can check the record counts. This is especially useful for those of you who work with web scale databases, which may have flexible memories. And so if you see the number of records all of a sudden decrease, unless you recently had some unfortunate press or something that explains that, that's perhaps a good time to not push an updated model into production. And so generally, a lot of these things are based on historical data, right? We have the idea that our pipeline used to work, and it working today should look kind of like it working yesterday. And the other one is domain-specific solutions, and we'll talk about those in the ML space. And that'll be all kinds of fun. Okay, and we can turn our property tests into validation rules. If you write property-based testing, please consider doing that. It's nice. The one thing is the real world can be a little bit fuzzier, so add some tolerances, you know. Accept that someone is going to come and say that their cat's name is Null and their favorite food is, I don't know, database record type. It's going to happen. And maybe you should stop your pipeline, but maybe if you only have 6 cats named Null, that's okay. So we looked at input schema validation with filter and flat map. If you're the kind of person who says, my data must always be correct, good job. I hope you have a lot of time on your hands, and you can statically ask Spark or Beam to make sure that all of your data is correct. And you can just tell it, this is the case class that should represent my data. These are the constraints. And it will do that and throw an exception. And then after a few weeks, you can get it to not throw an exception, but by then your data has changed. Yeah, okay. Yeah, great. Okay, right, and here's an example of relative rules where we say, if the bad values are more than 10% of my input records, maybe someone should take a look. Pick the percentage based on your data formats and valued partners. If you work with people who send you CSV files to an FTP server, you might want to allow 20%. If you work with people who upload JSON files to your website, you might pick a higher number. Or if you work with people in-house who have like a MySQL backend, you might pick a lower number than 10% of your records being invalid. So, you know, your mileage may vary. Oh, right, and here's an example. We can use Spark's own built-in counters. One of its counters that it has is records read. If you go look in the Spark Web UI or in the Beam UI, you can see all of the internal metrics that our data systems are collecting for us. Normally, nothing useful is done with these metrics. We just collect them because we're engineers. We have to collect metrics. If I don't collect metrics, am I an engineer? And the answer is yes, but it's all right. And so you could actually use these metrics that someone has put there, often at great expense. And yes, special business logic always goes at the bottom, and you have a lot of fun. Okay. Oh, and here's an example in Beam for people who like Java. It has the angle bracket. Oh, wait, no, it doesn't. Oops, we'll move, right? Oh, okay. I thought I had angle brackets to nom things for the Java people, but just pretend there's an alligator here. I'll replace this cat photo with an alligator for next time. And so we can say matched words, and we can write our own counters, and then we can say, you know, the unmatched words should not be less than matched words, or some other kind of rule here. Another thing that you can do, which I don't recommend putting in your main pipeline, if you're going to follow this approach, I recommend putting it in a separate sort of side pipeline, is if you keep historic versions of your data around, right? If, for example, I have a snapshot of yesterday's data anyways because I do this thing called backups, maybe I could see if my data has changed a lot since yesterday. And a lot is based on whatever doesn't wake you up once a month, but still is low enough it wakes you up a few times a year, right? You want this to catch the things, and it will depend on your users and what kind of data you're collecting, right? For example, my data about stuffed animals changes on a week-to-week basis as I collect more stuffed animals, but only by about 2 records per week. And so I can accept that kind of variation. But if I see 100 records go down, I need to have a conversation with my wife about returning the stuffed animals from her room to my room. And the same can be true with your data sources. Well, normally someone hasn't stolen your data. They just make a copy of it, but that's a different problem that I shouldn't talk about on camera. Okay, moving right along. The other one is, hopefully, you saved your previous output. You're not just overwriting it live. If you are, you have another problem. But you can write your output, and you can check to see, does today's output look like yesterday's output? This is really good for ETL jobs. It's really great. Doing it for a model is a little fuzzier, but we can look at this, right? And right, not just our data changes, our software is going to change behind us too. And you're going to want to catch that, right? And that we can catch maybe more in looking at the outputs and the execution time and the counters. There was this really amazing PyData London talk that looked at training the default models for a bunch of scikit-learn models across the different versions of scikit-learn without changing any of the data. And the model performance, it was not like this. It did not go up and to the right. It went up, down, up, discontinuous because it failed, and then and it's just, even if you're just upgrading simple packages, you may find things, well, scikit-learn is not a simple package, but if you're just upgrading small things, you can find really big changes. And often for the better, but you should check, because sometimes it is not. Yeah, okay. Yay, let's talk about ML. So just because we're doing machine learning doesn't mean that we don't need to validate our data. It is really important we validate our data because it's less clear on the other side what's happening with it. We get some new things to check. It's pretty cool. That being said, some of our old things probably aren't so great anymore. The output size of my model is probably not going to vary a whole lot, provided I'm training the same kind of model. Some exceptions apply. And eyeballing the results is a lot harder, right? And I'm not saying that you should be eyeballing your results all of the time, but with validation rules, when it goes wrong, a lot of us just end up kind of like going and looking at the table and being like, these 6 records look okay. Let's go look at some of the other rejected records that we saved to Kafka. And then we'll go look, and it'll be like, oh, no, it's fine. They're all rejected. But going and looking at some weights, I don't have a lot of intuition as to, if this hybrid feature has changed a lot. That doesn't tell me a lot if the model weights are shifting for this one feature. I have to sit and think about it for a while. I can't just kind of guess. I mean, I can, but it will go poorly. Okay. So how do we traditionally deploy our models? A human decides it's time to update their model. They have a really well-written runbook that tells them how to update their model. They read it, they do it, it doesn't fail. Human deploys their model to some percentage of their users. We observe the users do not die. We deploy it to all of our users. It's great, and we press deploy. But in practice, what happens is human is cornered by their stakeholders and forced to update their models because that's probably not what they get promoted for. I have a small amount of cynicism in me, just in case you haven't guessed. Spend a few hours trying to remember where the guide is, find out that you didn't write the guide, but you've got this IPython notebook, and you're pretty sure it's what you used to build it. It's called untitled_3.ipython notebook, but you don't have an _4, so it's probably the right one. And so you go, you run that, and it gives you a model, and you're like, well, this is a model. Deploy it to some percentage of users. You read Reddit or Hacker News or your preferred way to make yourself feel bad in the morning. I personally choose Twitter. It was really great this morning. And then whatever, it's fine, press deploy, no one died yet, right? If they died, they would have called me. If it was important, we'd be fine. I don't have to look at graphs. So the new possible practice for some people is that at some point you've realized that your stakeholders know where your desk is. And they keep finding you and asking you to update your model. And that is not what you get promoted for, so you write a shell script to do it for you. And you run this in cron on a single laptop because life is terrible. You use a workflow tool. Very fancy. It notices new data is available. Oh wait, no, we did use the shell script. It's the workflow tool which notices there's a new model for us and automatically puts that into production. Yeah, it's great. Remember that slide about people that did that? I really should have asked the intersection of people who have their jobs deployed into production what the percentage was of the failures, but I recorded those numbers separately to try and anonymize it a little, but that was, anyways, I wish I knew, but I imagine the overlap between people who deploy automatically to production and production outages is non-zero. Computer deploys it to some percentage of models. You have metrics about what your users are doing. You notice that they're actively engaging with your site more. You're really excited. You're a Silicon Valley company. Engagement is the only metric you care about. This is recorded. Okay, software looks at the monitoring graphs and sees that actually it's not good. All of your users left. They were sad users. Robot rolls it back, your pager goes off, your life is sad, human presses override anyways, deploys to production, your pager goes off again. Okay, great. Oh, yeah, there was no special part about, okay. So there are different tools that you can use for production monitoring, and you should use them. Kubeflow has some really nice built-in tools. If you're working within that ecosystem, different ecosystems have their own specific tools, and you should actually do your monitoring on those tools, and you should write a robot that rolls it back, because the robot doesn't have to wake up at 2 in the morning. And my life goal is to never carry a Motorola pager again. Okay, so here's our extra considerations. Oh, right. Some people like to use a fixed test set performance to measure if their model is good. This is really good, provided that the world does not change. And so if you don't keep jobs for very long, a fixed test set is fine. If you change jobs less frequently than your users change their behavior, for example, perhaps Hannah Montana is not as cool. Or I feel old again. Okay, fine. We can look at the number of iterations and the convergence rate. If we have a large spike in the number of iterations, or if our convergence rate, even if we get really, really good numbers, when we get unexpectedly good numbers, we should not deploy to production either, because that means something has changed. And once again, either we're a genius or our software is terrible. And I'll bet on the software. And you can look at the deltas in your model weights. If they don't tend to shift that much, and you have something where it's easy to look at the model weights, that's okay. I have not deployed systems like that personally. Instead, I look at the number of features that were selected and stuff like that. You can measure your cross-validation performance on your actual training data. A lot of people use this to auto-tune as well. If you do that, you're just, overfitting with cross-validation. So don't do that. It's a good way to get impressive looking numbers, but not actual performance. Right, so I want to be clear, even if our validation tells us that everything is good, cross-validation is happy, and it says we're going to make tons of money. Oh, and I'm going to wrap it up. It can still go wrong, and you'll still have to find someone and trick them into carrying a pager. Okay, serving is terrible, updating your model sucks, ending notes, everything is terrible, it's okay, don't feel bad. There are some tools to make your life less bad, but not all that much less bad. There's a reason they pay us money for these jobs. Here's a bunch of related resources. I'll tweet them so you don't, I didn't actually put the URLs in them anyways, so it's useless. There's some related packages. I did put the URLs. But I'll tweet this as well. Oh, and I cannot skip the most important slide. High Performance Spark is the best Spark book that I have written. And it pays the highest royalties of any book I have written. If you have an expense account, please buy several copies. Okay. Oh, and if you're excited in teaching your children or other people's children with their permission, distributed computing, I would encourage you to check out distributedcomputingforkids.com. I think it will be fun. I want to write a children's book, and this seemed like a way to maybe trick my boss into paying me to do that. If it doesn't work out, I'll just write it on the weekend, though. And yeah, so this is the second most important slide. This is the most important slide, and then we're done. Oh, cool. And I think we're literally out of time, but I'll be here, and I'm wearing a pink dinosaur dress, so you can come find me. Thank you all.